So in the previous lecture we have gone through indeterminate situation. So let us solve the first question, that is question 1, that is find the instantaneous speed of a body at t equal to 2, which moves according to law s is equal to t square. So this is the question that we need to answer. Now think about the question. The question is not like what is the value of a speed at t equal to 2. So if we think of the speed at t equal to 2, you can say that s at t equal to 2, this is gonna be 2 square, that is 4. But we are asking, this is speed, s is denoting the speed and not the displacement. This is a speed. So we are asking the speed at instant of time t equal to 2. Let us ask a question. What is the time at the moment? Look at the time in your digital watch. If it is digital, this would be good since you can measure it. Like you have a time like 12:30, even it is even 16, like this time. Even if we say that this is the time, then when we have asked the question what is the time, this move little bit. This is the second part. There are millisecond, nanosecond, and much more. So we are not asking the time, we are asking the instantaneous time. What is so uh, instantaneous speed at this moment is not 2. This is like s2 plus delta. Time is always positive, so delta is positive. 2 plus delta, this is gonna be 2 plus delta whole square, that is 2 square plus 4 delta plus delta square. Here delta tends to 0. Even delta tends to 0, s2 plus delta, this will tends to 4 plus 4 delta tends to 0 plus 0. So we can say that s2 plus delta tends to 4. Some student may say that sir, it is this is also going to be 4 and this is also going to be 4. Why we are doing like this? If he is asking this question, this means that he haven't understand the concept of limit. Limit is like a limit is working in the neighborhood behavior, and instantaneous speed is also working similar way. So to express this feeling, we can write this as limit t tends to 2, s is equal to 4. This means as time t approaches 2, speed approaches 4. This is the way of representing the instantaneous speed at t equal to 2. So this is the representation of limit. So we need to have exact meaning of any limit. So let us move on to the next topic, meaning of meaning of meaning of limit x tending to a fx equal to l. What does it mean? This is the simple representation, symbolic representation. Limit x tending to a fx equal to l. This is the symbolic representation. This means that as x approaches a, the value of function fx approaches the value l. So this is the meaning. As x approaches a, fx approaches l. This is not asking the value of this is not saying that the value of function at a is equal to l. This is not. This is not. This may be equal to l, or this may not be equal to l. And so this is not the meaning. This is just saying that as x approaches a, fx approaches l. Now there are two situations to approach a, that is x equal to a. There are two situations to approach a, that is approach from right and approach from left. So we have two concepts for this. We have right hand limit, right hand limit, and for this we have left hand limit. So there are two kinds of limit, right hand limit and left hand limit. Right hand limit means approaching from the right of a and approaching from left. Left hand limit is approaching from left side. So let us move on to the next concept, that is right hand limit. Right hand limit of fx at x equal to a. So let us have some figure of function, that is, let's say we have this function y is equal to fx, and this is x equal to a, and this is like any number, the value l. L is any finite number, it may be any number as well. So for right hand limit means as we approaches to a from right, a to right, at this point function has this value. As we move toward a, at this point function has this value. So you can say that as you move toward this a, function is approaching l. So for this we can have limit x tends to a plus, this plus sign says the right hand limit of function fx. Even we can also write the same situation like f of a plus, even sometimes we have f of a plus h. Now we have introduced this h, and what this h is, this h behave similar to delta. Delta is very small positive quantity. Even h is very small positive quantity. quantity, very very small positive quantity. Even at the introduction session we are assuming this to be very very small positive quantity, but later on as we have excellency in the limit, it will changes. It may be positive, it may be negative. Indian author use edge. Indian author use edge to represent this and avoid delta, since delta become very complicated to learn. So this is the right hand limit, and these are the three notation for the right hand limit. Similarly, for the left hand limit, let's say second, we have left hand limit of fx at x equal to a. So for this, let's say we have another function like this. We have like this at the moment, and this is x equal to a, and call this be any number L. In this case, we are moving toward a from the left, so you can see that, let's say this is the point. At this point function has this value, at this point function has this value. So you can see as we approaches from left, the function is approaching to L. So to express this feeling, we have the notation limit x tending to a minus fx. It doesn't mean that a is negative. It says that we are approaching a from the left, and this also can be written as f of a minus function f of a minus, or this can also be written as f of a minus h. Again, h is very very small positive quantity. You can say that if h become negative, then the same thing will behave like a right hand limit at x equal to a. This minus is in power and not at the this is not at this place. This is minus at this place. Here it is at this place. So these two are the first one was the right hand limit, and second one is the left hand limit. So to calculate the left hand and right hand limit, we have one question: how to calculate the right hand left hand limit for various questions. So let us have a question. So write down question: evaluate the left and right hand limit and right hand limit of the function fx equals, this is piecewise function, mod x upon x if x not equal to 0, and this is 0 if x equal to 0 at x equal to 0. So this is the question, to evaluate the left and right hand limit of the function at x equal to 0. So you can solve it. Before watching this solution, you can pause this video to watch the solution when you can work on the problem. So I am writing this solution like, let us calculate right hand limit. Right hand limit at x equal to 0. At x equal to 0. So the expression for right hand limit is limit x tending to 0 plus fx. Limit x tending to 0 plus fx. This is the expression for right hand limit. Here you can see that this is 0 plus and fx. You need to remember this expression, and the rest question also says how to proceed. Now at this place, this thing behave like as in a domain of function. You can see that this we are studying domain, so how we are studying limit, how what is domain doing here? As you can see that x is not exactly 0, this is 0 plus, so x is more than 0. So in these two cases, what is the situation? You can easily identify this is the situation. So at the place of fx we need to replace this quantity. So limit x tending to 0 plus fx will be replaced by mod x upon x. Now again, as x is more than 0, hence at this place mod x will be replaced by x. So this can be written as limit x tends to 0 plus x upon x. Now again, as x tends to 0, you will say 0 by 0, and this is not defined. You can say 0 by 0, and this is not defined. But this is not the situation. You can see this is not exact 0, since this is 0 plus, so this is not exact 0, and at this place you can cancel these out, cancel out these two, and this has become 1. So hence the right hand limit at x equal to 0 is 1. In the same way, we are calculating the left hand limit. Left hand limit at x equal to 0. The expression for left hand limit is limit x tending to 0 minus fx. Again, you need to see this is not exact 0. This is 0 minus. So x is less than 0. In this case, what fx need to replace? X tends to 0 minus. What should be the function in the place of fx? Even x not 0, this should be this value. So mod fx, mod x upon x. As you can see, x is less than 0, 0 minus, it's less than 0. So mod x will be open as minus x. So limit x tending to 0 minus, this is minus x upon x. Again, this is not exactly 0, so you can remove this, you can get minus 1. So at this place, you are getting right hand limit as 1 and left hand limit as minus 1. Thanks. So let us move on to the next example, and that is next example. It is like next question we can have. Question: evaluate the left and right hand limit and right hand limit of fx equals 3x plus mod x upon 7x minus 5 mod x at x equal to 0. You can solve it your own. Take time around 3 to 5 minutes. to solve this question. And when you can see, you can watch this video how we are solving this. So to find the left limit and right hand limit, so let us have left hand limit at x equal to 0. Again, the expression for left hand limit as s equal to 0 is limit x tending to 0 minus fx. At this place we need to write this. So limit x tending to 0 minus fx would be 3x plus mod x upon 7x minus 5 mod x. This is the left hand limit. Now again, as you can see, this is behaving like a domain. X is the variable here, so x is less than 0. When x is less than 0, this is negative, so mod x will be replaced by minus x. So limit x tending to 0 minus, this can be 3x minus x upon 7x. At this place, this would be minus x, minus minus, we will get plus sign here, plus sign 5x. So this would be limit x tends to 0 minus, this would be 2x upon 12x. You can get this. Now again, you can think of indeterminate situation. Which indeterminate situation it is? You can say if we apply 0 minus, this is 0 by 0, this will get multiplied by 0 by 0, 2 multiply 0 tending to 0, this is situation 0 tending to situation 0, this is 0 by 0 form. So when we were discussing the 7 indeterminate form, you can see how the exact indeterminate situation look like. This is tending to 0 by tending to 0. At this place, x, these two x behave in same way, and this is not exactly 0, hence we can remove this. So left hand limit is going to be equal to 1 by 6. So left hand limit at x equal to 0 is 1 by 6. Let us move on to the right hand limit. Right hand limit at x equal to 0. We can have like limit expression for right hand limit x tending to 0 plus fx. 0 plus fx. This is the expression for right hand limit. You need to remember this, and rest the function will proceed. Function will tell how to proceed. This symbolic meaning will tell you how to proceed. So limit x tending to 0 plus fx will be replaced by this 3x plus mod x upon 7x minus 5 mod x. Here you can see that x is more than 0 plus, so x is positive. At this place you need to remove mod x by x. So limit x tending to 0 plus 3x plus x upon the same way here 7x minus 5x. This can be written as limit x tending to 0 plus, this is gonna be 4x upon 2x. So here still you can say this is 0 by 0 situation, 0 by 0 indeterminate situation, 0 by 0 form. At the moment you can get how indeterminate situation looks like. You can say this is 0 tending to 0, 0 tending to 0. This x is behaving in same manner, so you can remove this, you can cancel out these two, and this is equal to 2. Hence right hand limit x equal to 0 is 2 and left hand limit x equal to 0 is 0. So this was the left hand limit and right hand limit part. Now we are moving on the next concept, that is existence of limit. Existence of limit. Existence of limit. When limit exists at x equal to a. You can see we have calculated the limit at x equal to a, right hand limit, that is limit x tending to a plus fx, and like let's say call we L1, and left hand limit x tending to a minus fx, call this be L2. So we have calculated these two limits at the. Now to for existence of limit at x equal to a, there must be a situation like limit x tending to a minus fx must be equal to limit x tending to a plus fx, and that must be equal to something like L. For this situation L1 L2 has to be same. For this situation L1 L2 has to be same, and that should be equal to L. And this L must be a finite number. L must be a finite number. What if it is not a finite number? This may be infinity. So if we have limit like limit extending to a minus fx, it is like infinity. Then what does it mean? This means limit does not exist. Limit does not exist. This, you can say this is tending to infinity, but this is implying limit does not exist. So for existence, this limit should be finite, and this right hand limit and left limit both must be a same number, and that same number must be a finite number. Only then we can have, if left hand limit and right hand limit for this function at x equal to a are same, then we can say limit x tending to a fx equal to L exist. This L number must be a finite number here. We have another example to get the total concept of limit. So, and we will discuss it in a proper way. So just see the next question. Question is, discuss the existence of limit. Discuss the existence of limit for fx where graph of y is equal to fx is as shown. In figure, I am making a figure here. You just see. You can just see. Let's say this point is 1, this point is 2, so this is 1, 2, 3, 4, 5, 6, and this is x-axis, this is y-axis. So we are going to make a function fx. So let's say it's a straight line, and at this place we have a open hole, and at this one we have a value like this 1. These are at same height. Let us make same height line. So at 1 it is 1, at 2 it is a circle, open circle, open bracket, and this is the situation. And at 2 to 3, at 3 we have this, and connected by a line. At 2 we have value function at 2 is this, and at 4 like this, 5 this is like this, asymptotic behavior, and at 6 we have situation like this. This is saying open bracket, this point. So let's say the fx has domain like 0 to 6 at this place, and minus we do not have value of function at 4 and 5, so we need to remove this 4 and 5 to r. This is the function as we are approaching here. So this is the function, and we need to discuss the limit of function at various points 0, 1, 2, 3. So first question is whether this whether the limit of function exists at x equal to 0. Existence of limit at x equal to 0. At the point 0 you can see there is right hand limit and no left hand limit at the moment. So whether the limit exists or not, so you can say in such kind of situation we need to calculate only one limit. At this moment we need to calculate the right hand limit only and not the left hand. Even you can say that in the previous definition we have seen that if right hand limit is equal to left hand limit only, then will limit exist. This is not the way. If we have situation like this, we calculate only right hand limit and say limit exists. At the moment if we say limit x tending to 0 plus fx, what should be the answer? What should be the answer? Right hand limit at x equal to 0. What should be the answer? You can say you can see at this moment the function is having this value. As we move toward 0, this move toward 1. So if we move toward 0 from right, this number move toward 1. So the limit is 1. Limit of this is 1. Even limit x tending to 1 minus. What is the limit? A function at 1 minus is left hand limit at 1. So you can see if we move this function as this value, as we approaches toward 1, this value approaches toward 0. So 1 minus fx is 0. And what about f of 1 plus, means the right hand limit at 1. So you can say this is the right hand limit approach. So f of 1 plus is 1. And in the same way, whether limit exists at equal to at x equal to 1 or not. So you can say that limit x tending to 1 fx equal to does not exist. Does not exist. Why it is so? Since right hand limit is 1, left hand limit is 0, so this is not does not exist. They are not approaching the same number. Even f of 1, you can see f of 1 we are getting is f of 1 is 1, but limit do not require the value of function at this point 1. We will discuss the same problem in the next video. So move on to the next video.